So um, let's make a review about the programming assignment that we had, okay, in the laboratory. So the EMNIST, the letter detective, okay. So what is the assignment is all about? We already trained the model on MNIST digits from 0 to 9. So the notebook upgrades the difficulty by switching to MNIST letters from A to Z, or 26 classes. The main difference are more classes. We have 26 instead of 10. More variation or noise in handwriting. The distances, letters, labels are one index. So we must shift them to zero index for PyTorch training. So we import and set up during our writing the code. Okay, so we have the usual PyTorch training stacks like Torch, Torch.nnn, Torch.optim, Torch Vision the datasets, and Torch Vision transforms. Data loader for batching. Some provided helper utils it test device selection. So the GPU if available, like CUDA. So otherwise CPU if we don't have um, the GPU. So we set a data path folder for MNIST so it won't re-download every time. So one is so the first way we do is after that is the letter images datasets plus preprocessing. We load the datasets. So we load images through Turkish Vision's datasets tools stored under our local data path. The notebook sets up both training split, test split. We explore the and next after that we explore the raw data. We inspect what a sample looks like before training. Images are 28 by 28 grayscale pixels. Labels represent letters. EMNIST images often need orientation corrections, common MNIST gotcha. Okay, so um, next we did is preprocessing the images, preprocessing of the images. This is where the model prepares the images in a way that the model can learn from consistently. So the key ideas in preprocessing is we convert the images into tensors, okay, like to tensor, normalizing values typical for stable training and fast training, okay, um, uh, fixing image orientations, rotate or flip like that. We implemented the correct image orientation, like we rotate it to 90 degrees, vertical flip after rotation. That makes the characters upright the way we expect, loading the data in batches. Instead of training on the entire data set at once, we train on mini batches using data loader. So here in that laboratory, we have 5 exercises. So this is a first exercise one all about we create the MNIST data loaders. We created two data loaders, the train data loaders and the tested data loader. So the train data loader, uh, uh, we use the parameter shuffle is equivalent to true. It's important because randomized batches each import so the model doesn't memorize order. So in the test data loader, we set that parameter shuffle into false because we get evaluation stable and deterministic. We also made the batch size given to 64, the default which is a standard practical choice. And after that, we build the neural network. Okay, so the assignment uses simple baseline model to focus more on training pipeline than fancy architecture. So the exercise 2 all about is initialize the EMNIST model. We built a model using the NNN and that sequential. So the flatten turns to um, B12828 into B784. We convert it like that. Okay, so the linear 784 to 256. We set it 256 because of the baseline. We set that the parameter. Okay. Plus the activation function is rel. Next, that is the linear 256 to 128 plus rel activation also. And the final layer outputs logits is 128.26. So the more details here is the final layer outputs row logits, not probabilities. This is correct for cross entropy loss. So the loss function is n-ended cross entropy loss. Okay, for multi-class classification we use that. So the optimizer is Adam with the learning rate of 0.001. So we wrote the optimizer, okay, and it doesn't break anything, but we can clean it. So just one assignment, and after that is we train the training and evaluation. This is the core of the assignment in the notebook. We train the loop structure, tracking loss, accuracy, and correct evaluation paper. So the training model in the exercise 3, train epoch. Inside each batch, we did the standard training steps. First is move inputs targets into the device. The second one is we shift the targets down by 1. So EMNIST letters are from 1 to 26. PyTorch expects it's 0 to 25 for index. The third one, okay, the third step is to optimize that 0.grad. After that is the forward pass, like outputs equivalent to model um, inputs, and the loss function is given loss function outputs, comma targets. So the back propagation loss that backward, and lastly we update the weights. We also track the running loss, number of correct predictions, total predictions. Then we computed the average loss, like running loss divided by the length of the train loader. The accuracy percentage, like the number of correct prediction divided by the total predictions, okay, times 100. So important detail is here is the function returns like model, comma, average loss. Um, even though the docstring mentions accuracy too, we print accuracy is correct, but it's not returned. That a big issue for this notebook since we print it, but returning it would match the docstring. And the third one is evaluate it, is the evaluation. So that's in the exercise 4, we evaluate it. Evaluation is different from training because model that eval, the function that turns off things like dropout if and such as batch room behavior if present. That Nogra disables gradient tracking for speed and memory savings. Then loop through test batches, move the device, subtract 1 from labels again, run forward pass, complete predictions with Argamax, accumulate correct total, compute model test accuracy. This is exactly the right evaluation pattern. Putting it all together and like that. So the exercise 5 is we're going to put it all together, train and evaluate. We wrote the outer training loop for epochs called train epochs. Second one is called evaluate and print results. Finally return train model. This is typical train for an epochs and check validation test accuracy each time. Saving the train models. The notebook includes a section to save the train model so we can reuse it without retraining. Usually this is done something like saving model is state and later reloading into the same architecture. The code is train 1 3 years later, especially for decoding step. And this one, the decoding the secret message. After training, we use the model letter detector to decode words made of individual character images. Decode words, images, words, comma model, comma device. This function sets model to evaluation mode, disables gradients, loops through each character image in a word, adds a batch dimension, width, and squids. So the shape becomes 1, comma 1, comma 28, 28. Runs prediction takes class index with output max 1. Converts the class index to the lowercase that are using the Python codes or like that. Then it joins all predicted letters into one decoded word. This is a clean practical example from training inference. So the key concept here is uh, how to load datasets with dark vision and build data loaders, why pair processing and normalized matter, device management, CPU versus GPU, the full training pipeline, train versus evaluation, no gradient during evaluation, gradient steps, zero gradient, forward, loss, backward step, how to compute accuracy correctly, turning model outputs into classification, predictions like argmax, using a trained model so for the real inference decoding methods. And that's it.